In this class, we will discuss about another type of discrete probabilities distribution, which is Poisson distribution. So this Poisson distribution is nothing but an extension of binomial distribution. So it's a limiting form of binomial distribution. So as n tends to infinity, so this binomial distribution will be transformed to will become Poisson distribution. So when the number of trials are infinite, so like that you can take, or when the number of trials n is very large, then we can take that binomial distribution as Poisson distribution. In this case, this value of n into p, you can take it as a finite number. So n into p can be taken as m here. So n into p, as here this p is very small. When p is very small and n tends to infinity, so when you multiply these two, n into p, it becomes a finite number m. Finite number. So the probability density function for a Poisson distribution is given by p of x is equal to m power x into e power minus m divided by m power x into e power minus m divided by x. So this is the PDF, probability density function of Poisson distribution. So if you calculate the mean and standard deviation, so in the case of Poisson distribution, if you calculate the mean using this formula, sigma x is equal to 0 to infinity, because n is tending to infinity, x into p of x. This is the formula to find the mean of a discrete probability distribution. If you simplify this, you are going to get the value as m. M means that is n into p. Similarly, variance v is mu. Variance v is given by sigma x is equal to 0 to infinity. Sigma x is equal to 0 to infinity x square p of x minus mu square. So if you simplify this, so you will be getting this also equal to n. So that is n into p. So now if you take the standard deviation is square root of variance sigma root of v, which is root of m. So these are the characteristics of Poisson's distribution. So it is an extension of binomial distribution. Now if you take up some problems on Poisson distribution, let us take problems on Poisson's distribution. Let me take a problem like this. Problems. First problem. So develop a Poisson distribution or fit a Poisson distribution. Fit a Poisson distribution. Fit a Poisson distribution for the following data. And find the theoretical frequencies. So x and f, so like this here is given. F is the frequency. So for different values of x, frequencies are given 0, 122, 160, 215, 3, 2 and 4, 1. Yeah. So we have to fit a Poisson distribution for this given data. So this is the distribution. So we have to fit a PDF. PDF we have to find out. Probability density function P of x. We have to find out. Okay, for that we need to find the value of m. So m we have to find out. Once you find out the value of m, you can easily write this PDF. So to find m, so we are first let us find out mu. Mu is given by sigma fx by sigma f. So this is the formula. When frequency is given, this is the formula. So sigma f into x. F into x, it is like this. Sigma f into x. So 122 into 0 is 0. Plus 60 into 1 is 60, plus 15 into 2 is 30, plus 2 into 3 is 6, plus 1 into 4 is 4. This is sigma fx. Divided by sigma fx, there is a sigma f is sum of all this 122 plus 60 plus 15 plus 2 plus 1. So if you simplify this, you will be getting 0.5. 0.5 is the mean. Mu value. Now we know that mu is equal to m. In the case of a Poisson distribution, the value of mu is equal to m. Therefore, m is equal to 0.5. So therefore, what we can write P of x is equal to the PDF is m power x e power minus m divided by x factorial. So m is here 0.5. So 0.5 to the power x will be e to the power of minus 0.5 divided by x factorial. So this is the PDF function for the given data. Now once you get this, now we have to find out the theoretical frequencies. To find the theoretical frequencies, let us assume f of x is equal to the sigma f into P of x. Sigma f is the sum of all these things, which is 200, into P of x is this 0.5 to the power x into e to the power of minus 0.5 divided by x factorial. Yes. Now this is the expression for f of x. Now by putting the values of x here in this expression, you can get the values of the theoretical frequencies. So these are the observed frequencies. For these observed frequencies, we have fit the Poisson distribution. Now to get the theoretical frequency, so theoretical frequency is given by this formula. This is the formula. So here, by putting the values of x, you can get the corresponding values of theoretical frequencies. Now let me put if x is equal to 0, what is the value of theoretical frequency? So f of 0, it will be f of 0. So it is 200 into 0.5 to the power 0 into e to the power of minus 0.5 divided by 0 factorial. 0 factorial is 1 here. 0.5 to the power of 0 is also 1. So 200 into e to the power of minus 0.5. So if you use the calculator, you are going to get the value as 121. So observed frequency is 122, theoretical frequency is 121. Suppose if x is equal to 1, next value is x is equal to 1, f of 1, put x is equal to 1 here, 200 into 0.5 to the power of 1 into e to the power of minus 0.5 is a constant divided by 1 factorial. So 1 factorial is 1, 0.5 power 1 is 0.5, so 0.5 into 200 is 100, 100 into e to the power of minus 0.5, which you are going to get it as 61. Of course, 60.5 you may get, round it up to next whole number, because frequency cannot be a decimal. Next, if x is equal to 2, f of 200 into 0.5 to the power of 2 into e to the power of minus 0.5 divided by 2 factorial. So if you simplify this, 2 factorial is 2 into 1 that is 2, this is 0.0025. If you simplify this entire thing, you are going to get 15. So theoretical frequency is 15, observed frequency is also 15. If x is equal to 3, f of 3, so 200 into 0.5 to the power 3 into e to the power of minus 0.5 divided by 3 factorial. If you simplify this, you are going to get 3. So observed frequency is 2, theoretical frequency is 3. Then lastly, x is equal to 4, f of 4, 200 into 0.5 to the power 4 into e to the power of minus 0.5 divided by 4 factorial, which you will get as 1. So the answer is 1. Not 1, it is 0. Theoretical frequency is almost 0, nearly equal to 0. You will get a very small number, you can take it as 0. So observed is 1, theoretical is 0. Now if you add this entire thing, if you add, you are going to get 200. That is your sigma. If you add these also, 121 plus 61 plus 15 plus 3 plus 0, that also you should get 200 only. So these by fitting a distribution, you can always calculate the theoretical frequency and you can compare with the observed frequency. So in the case of Poisson distribution, it is an extension of binomial distribution when n is very large, when n tends to infinity. So this mean value m will be n into p, where p is a very small number. So when p is very small, n tends to infinity, then binomial distribution will be converted to Poisson distribution, and the mean value is m, variance value is m, standard deviation is root m, and we can fit a Poisson distribution for a problem like this.